Okay, good morning, everybody. What we're going to do, before I say too much, we're going to go right to a short video. It's 4 minutes long, and I think we have good audio. We tested it earlier, so let's see what we can do.
Hello, my name is Dr. Judy Benign. I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Okay. So that's a nice cartoon, but it is painfully realistic. How many people here are active researchers? Yeah, okay, so you know, I can relate to this very much as well. And I like to show this video at the beginning of this talk because it begins to capture this huge constellation of issues that don't seem very systematic right now. They're just kind of these issues that we put into what we call data stewardship that is only just now starting to be recognized as something that we need to get a handle on and be more systematic about if we're to actually get to some level of reproducibility and reusability with our data. So it's a nice video to show by way of introduction. Let me just say maybe a couple words about myself, because you'll be listening to me for this morning and part of the afternoon. So my name is Erik Schultes. I'm an American living and working in Leiden at the Leiden University Medical Center. I've been there for about 8 years. My own research in biology has been always data intensive, and so it's kind of natural that I migrated into this data stewardship space. What I will attempt to do in the next half hour is kind of frame the big problem, this data stewardship issue, this context, and then within that, I'm going to try and make an explanation for this idea of fair data, and then I'll show you some work that we've done in the last 2 years to show kind of an implementation of fair data, and then give you a sense for what might be needed in terms of training, and maybe for yourself, but also for what we think is a new discipline that's emerging called data stewardship. So we think there will be people who are likely to become professional data stewards, because the topic is that hard. It's complicated enough. I think it deserves its own expertise. Okay, so I'm going to stand here so I can see the screen with you. I think everyone in this room is probably aware of the big problem that we're facing. Data sets are getting bigger. The amounts of data that we're generating are getting much larger. There's a growing awareness that data is not very reusable in the way we've been doing it traditionally, the way we've been generating it and sharing it. And if these data sets continue to get larger and larger, it becomes a big problem. There's also a growing awareness of data reproducibility issues. And we think that data stewardship and ideas behind like maybe just having better metadata could help with reusability and with reproducibility. But everything's really kind of driven, I think, by just the sense of data overload. So many of us are like this gentleman on the beach, going about our work in a way that we've been trained and the way we think seems reasonable, but very soon there's this impending tidal wave of data that's going to come crashing down, and we need ways to deal with it. That's kind of the negative view on this. The positive view is if data were reusable, and again, if the data sets and the amounts of data are getting so large that more and more the computer is going to have to assist us in managing our data, if that's true, then there's also some really nice potential here. If we can get at some level of interoperability into our data, automatic interoperability, then new interesting things open up. And these are some commentaries from the editor at Nature Genetics, Miles Axton, and I like these 2 points that he's made. He's saying that in the first case, data integration can allow us to ask new questions in science that we weren't able to do before. So just by being able to integrate data in a more automatic, widespread way, it should be possible to ask questions that are even beyond the scope of ordinary research proposals. And kind of as a corollary to that, it should be possible to do new experiments and to generate new insights and new conclusions without having to necessarily generate new data. And that these are the promises if we can get data to be much more findable and accessible and interoperable. Okay, So that's kind of the mission. That's what kind of the vision. You know, there's problems and there's potential. So what's this idea of data stewardship? And I'm showing you a picture now of some landscape in the Netherlands. You can see the windmill, the classic iconic windmill. This is called a polder, and this landscape. And it's a beautiful landscape, but it's not there by accident. The polder is maintained as an artificial thing by people who have technology and skill and know-how. They know how to maintain this environment. And in fact, there's even a kind of ethic to it, or an attitude about future generations. So this landscape is no accident. There's an active stewardship for this land, for the polder. So it's a nice background for this idea of stewardship. In the context of data, one way of framing this is that, you know, in your data management plan, which you might execute over the course of your research project, you're trying to figure out how you're going to manage your data while the funding is there. Data stewardship is trying to take a longer view. What happens when the funding is over? Then what happens to your data? And if there's not a plan for that, then that data will eventually disappear and degrade. So data stewardship is really, in my mind, it's a plan for maximizing the reuse of your data beyond the project. And then, just as we saw with the panda bear and the brown bear having their discussion, there's just kind of this large constellation of seemingly unrelated issues that go into making your data more or less reusable and reproducible. So I'm just listing some things here, right? So there's differences between sharing your data and publishing your data. There's issues of like open versus closed versus secured data. And, you know, what do these things really mean? They have legal definitions behind them in some cases. There's licensing and fees that can go along with your data, something that researchers don't usually think about. There's differences between authors of data and owners of data. So think about patients, for example. We can ask questions about who paid for the data. You know, what rights do insurance companies have in generating patient data? There's all kinds of issues of the scaling when you're talking about very large data sets. How are you going to maintain this data? You could serve it, and maybe you want to serve it at a very high level of 24/7 uptime. That costs money, a lot of money. But maybe you want to, maybe your data is good enough just for, or it's good enough just to do some archiving for your data. So there's all kinds of issues here: machine interoperation, human language interoperation. These are things that you can consider when making decisions about the data stewardship plan for your own data. But most of us, as practicing researchers, as Annalisa said, we're not trained in this. And in a way, I don't think we should be trained in it, because we've already done a lot of work to get at a very high level of expertise in our own domain. And to really get a professional handle on these issues is going to require a professional to come in and do this work. So this is where the FAIR principles kind of originated from. It's kind of considering this constellation of issues. And FAIR is an acronym for data that is findable, accessible, interoperable, and reusable. It can refer to data as well as services, so like the cytosynth program in the Panda video. And FAIR data was explicitly created, these principles were specifically created with human-machine interoperability in mind, with the idea that there's so much data coming at us now that is beyond human comprehension. And even people in a very narrow discipline cannot really keep up with the research these days. So the machine, more and more, must become a helper. And if the machine is to do that, then it has to understand the data in the same way that we do as researchers. So that's the idea behind the FAIR data principles. It's very popular these days for people to be talking about FAIR data, like the G20 or the G7. But I think, at least in my experience when I'm talking to people, they're often not aware that we actually published in April of 2016 a list of 15 FAIR principles. and they're pretty well defined. So it's not just 4 principles or not just 1 principle, but there's really these 15 different things. And we could take time. I'm happy to take time later today to kind of go through these. They're, for people who are not computer scientists, they may be a little bit outside your ordinary everyday life, but they're not that hard to understand. So we can go through it later today. But just to kind of give an overview, the principles associated with findability is really just to say, hey, if I can't find your data, then I'm never going to reuse it. And a lot of times you'll say people will say, hey, my data is open and it's out there, but if nobody can find it, then it's effectively not there. And in fact, the money you spent generating that data is effectively wasted. So findability just has to do with, how can we get things to be discoverable by humans and machines? The accessibility component, there's 2 issues here. One is that, and I'll make this point in a few slides, but there's a difference between being open and being fair. The A in fair, accessibility, is saying nothing more than just an explicit protocol for accessing the data. The data could be open, the data could be closed, but at least the computer knows how it's going to access that data. And the principle here at the bottom, I think is also important. We think in this world of fair data that your metadata, the data about your data, should be persistent and should in itself be a kind of publication, so that one day when your data set disappears, because unless you're going to spend a lot of money into the future to keep it there, it will disappear. We still think it's important to have your metadata be persistent. That way we can always see what has been done, and we can maybe figure out ways to access it even if it kind of goes offline. So we've been saying in our group that in some ways your metadata is even more important than your data, at least for making it fair. Making your data interoperable is, I think, the biggest challenge, because somehow you got to take a world of, almost like an infinite variety and diversity of data, and you're going to try to help the machine to understand what it's looking at. So that's a big challenge, but I can show you some examples of how we're doing that. And then reusable. This has more to do with like metadata that tells you what you are allowed to do with this data. So it has to do with licensing and fees. It has to do with being able to encode what we call the provenance of your data. So if you're going to do a particular kind of an experiment, you're using particular kinds of high throughput machines or particular kinds of assays, more and more it's going to be necessary to kind of embed that knowledge into your metadata as well. Again, not an easy thing to do, but something that people are working on at the moment. So there's kind of room for innovation in that space. And then, we just say that there's lots of different research communities out there, and they all need to define for themselves what this provenance should look like and what that metadata should look like. So we can come back to that later if you want to in more detail. I can direct you to this website here, the GoFair website, which came up only last week. But we have a kind of a human readable explanation of what the 15 FAIR principles are all about, and some examples and some links to resources that you can get to take a look at what these things look like. Okay, so what is FAIR data not? FAIR are these high-level architectural principles that we think, if followed, would lead to increased findability, accessibility, etc. But FAIR is itself not a standard. And we actually borrowed this construction from the people who actually created the internet. They decided very early on, 30 years ago, that there would be some principles that would allow a lot of innovation in terms of standards within the space. And that turned out to be amazingly successful. And so the architects of the 15 principles borrowed that same model. They are principles to which many standards could be applied. FAIR is not equal to semantic web. Just a quick show of hands. How many people are familiar with semantic web? Okay, so maybe not too relevant here. Semantic web is it's like a 30-year research project in trying to get human-machine interoperation. So it's relevant to FAIR data, maybe, but not necessarily, it's not a standard that must be in place. FAIR, as I mentioned, is not equal to open or to free. So there are lots of examples of open data that are not FAIR, and there are lots of closed data sets that could still be perfectly FAIR. For example, if you have patient data, there's just no way you can make that open. But you can have an expression in the A principle about how this data can be accessed if you need to. Yep. And then lastly, yeah, FAIR is not just for humans, but it's also for machines. Okay, so now I'll just do 3 things here. I'm just going to give you a quick introduction to where this all came from, kind of historically, and then I'll just show you a couple examples of what the technology looks like and some training that we're developing to go with it. And I think that'll be a good introduction for this morning. Okay, so what's this idea? Where did it come from? There was a meeting held at Leiden University, a Lorenz workshop meeting in January 2014, and that's where this acronym was coined. A pretty effective acronym, it's done well. For the next year, there was blogging about it. Force 11 really drove the formation of these 15 principles. And there was commentary. In April of last year, 2016, the European Commission announced its European Open Science Cloud initiative, and it's something like a €6 billion project to build an open workspace to try and overcome some of these reusability and reproducibility issues. And the notable thing about the European Commission's announcement was that they were committed to FAIR. They even said this is a hard enough job that we can imagine making it at some point mandatory that 5% of your research budget must go to this data stewardship issue. And if you just think about like Horizon 2020 programs, which I think was like around 80 billion in recent years, so that's 5%, that's like 4 billion annually for data stewardship. So it's recognizing that there's a serious need for this. And then that budget could go partly towards the formation of what Europe thinks they need, is like 500,000 trained, professional, certified data stewards. So they even see it as a new profession that's coming up. The National Institutes of Health in the US have an analog to this. They call it the Data Commons. They were setting aside up to like 25% of research budgets for data stewardship. So 5% might itself be kind of conservative. Then there's this other organization called the Health Research Board, which has been actually quite an early mover in this space, and I think very open-minded about this, and even to the point where, how can we begin to implement some of these things. I'll talk about GoFair in a minute. That's where my job is nowadays. But then, yeah, Annalisa mentioned that there's other irrelevant organizations committed to FAIR data as well. There's also the World Economic Forum has an interest now in this as well. Okay, so there's the European Open Science Cloud, and then there's GoFair. And GoFair was created as an initiative to do kind of a rapid implementation of European Open Science Cloud components. And so it's kind of a bottom-up rapid implementation consortium. In June of last year, there was already announcements by the German and Dutch governments that they were interested in forming an international GO-FAIR office, GO being global open fair, global meaning covering all research disciplines, sort of global in its view, and open in that anybody can join. I mentioned there's a website that came up just last week. So from June till now, there's been a lot of progress with the GoFair office. It's been funded. The Dutch government funded it first, and now there was an announcement just Friday that the German and Dutch governments are now both investing in the GoFair office. I'm sharing the website. Please take a look at it, but it's still an early stage for this website. Expect a lot of changes to come, and maybe, you don't need to spread it too widely at the moment, because there's going to be a lot of changes coming to the website in the next 6 months, I think. The office is now physically located at Leiden University. We're in this little wing over here, and it's just 4 people in the office at the moment. It's designed to be a small office. The idea is that the GoFair International Support and Coordination Office is just trying to synchronize a lot of different groups that are coming up with technologies to do fair data and to just try and to prevent the reinvention of the wheel over and over. So our job is just to kind of coordinate among a lot of other activities that are already going on in fair data. So there's GoFair. We're organized as like Go Change, Go Build, Go Train. And the Go Change, I think, would be an example. HRB would be an example. It's an organization that's trying to figure out how to adjust or nudge incentives so that researchers and funding agencies and publishers can start practicing better data stewardship. Go Build and Go Train, it's more like we're trying to build some reference implementation, some technologies that demonstrate fair data. And we can see from that technology that there's some training that needs to happen. So I'll just show you a couple of slides about the Go Build and the training. And we call this our reference implementation. This is one way to do fair data. It's not the only way by any means, but we are trying to build a system that if you were to go through this workflow, you could be guaranteed to be hitting all or most of these 15 FAIR principles. So we're just trying to make it more routine, more automated where we can, to make it simpler for a data steward to actually make fair data. And the way we think about it, the way we've conceived it was, okay, we've got data in some format, maybe a spreadsheet, but more and more, we're going to have metadata. And with time, it will become more and more sophisticated metadata. And we committed to a markup language called RDF to express this data and metadata in a way that the machine can understand. It's kind of like XML or HTML. It's just a way to mark up the data so the computer knows what's going on. And this process can happen in a manual way. It's just you have to understand RDF and the data, and you can encode it. But what we've built is something that we call the Fairfire. This is just a piece of software. It's based on OpenRefine, which is a kind of data munging. It's like a big spreadsheet, but with data editing features. We've added capability to add unique identifiers, and unique identifiers that are registered at certain registries so that you can uniquely identify your data elements. And you can do that, you can mark that up by using what are called ontologies or controlled vocabularies. So you can go out there and you can find very systematic descriptions of certain areas. So you can get an ontology of proteins or an ontology of diseases or an ontology of phenotypes. And you can use that structure to mark up your data so the machine will understand. And the data model here is just to say that you've got tabular data, you've got elements in that data, and they have relationships to each other. You express that as your data model. And basically what you can do is encode your data and your metadata in a code that the computer can follow. And then if you do that, we have a capability of, we say, pushing it to what we call a fair data point. And a fair data point is a way for your data and your metadata to be published to the world. It's a publication platform, essentially. So what we envision is a world of fair data points. And if you have that, you can design very sophisticated search engines that can index at a very fine-grained level the metadata and your data itself. So let me show you what the fair data point looks like. It's really just like a couple layers of metadata that sit on top of your data. And so what you see here is, there's a fair data point at the highest level. And within a fair data point, there's one or many catalogs. And within a catalog, there's one or many data sets. And within a data set, there's one or many what we call distributions. And this is a structure, this hierarchical arrangement is coming from an ontology, a standard ontology for metadata. It's called the DCAT, or data catalog. So we just borrowed this ontology. We created this FAIR data point that allows other computers to come in here and ask questions about what's going on. And we do that through a standard internet protocol. So here's what we are saying, that you might have a data set, in this case as a text file, but maybe we also wrote that data set as RDF. So it's the same data, but just two different formats or distributions, but they're in the same data set. Here's another data set that's in a third format. But the computer knows now what these formats are. And in the case of the RDF, the computer can even know what a single data point is in your table. It can go through the row and column and actually understand that it's a blood pressure measurement or it's a readout from some other assay. We have image files. So again, it's even if you don't verify your data, you can still verify your metadata. And you can put that on a FAIR data point and just point to your data. That's the idea. Try and make this easy as possible. So these are the kinds of things that are standard in DCAT, the kinds of metadata that are standard in DCAT. But we can imagine elaborating that to include the complicated provenance of your experiments and things like that. My colleague, Rob Hoofd, also from the Netherlands and from DTL here today, he's going to talk more later about the Data Stewardship Wizard. And this is a tool that helps you to design your data stewardship plan. And I think there's components of this that can help you decide what you want in your metadata. This is a screenshot of a real FAIR data point. And what you see here are the catalogs. If you were to click on these URLs, you would actually get then to the data set level. If you click on one of those URLs, you get to the distribution. But a computer can actually query through here and find what it's looking for given the query that you gave it. So here's what it looks like. Here's what it would look like in practice for us researchers. Right now, if you do a Google search for, say, inhibitors of P65, you're going to get like 500,000 hits. Most of these are research articles, and so now you can start reading papers. And because we can't really text mine behind paywalls, there's going to be lots of inhibitors that are buried in the text that computer can't usually get to, or it's going to be in a table or in a TIFF image or in a supplemental link. So it's just hard to get back the inhibitors, even though they're maybe contained in those papers. In a world of FAIR data, your query can be much more elaborate. And there's different ways of encoding this, but we could say, for example, find me all known low molecular weight inhibitors of the human P65. Right, that's going to resolve a lot of noise in your search already. Separate the list based on those found in curated databases from those that are found in self-deposited archives. Keep track of the licensing and citation information, and if you find data that's not public but still relevant, then give me the contact information of the people I need to talk to. And these kinds of queries should be routine given the metadata that would be embedded in a FAIR data point. Quite recently, we published a paper on metrics for fairness. So given that you've posted your data on a FAIR data point, we can now run scripts that automatically determine how compliant you are with the 15 principles. And so there's you can learn more about that at the website. This is a paper that, again, we just kind of released it on Friday. But there's 14 FAIR metrics that we have and a framework for different research communities to design and implement their own metrics. Because we think the metrics that are designed in a geophysics community are going to look a lot different than the metrics that might be designed in a biomedical research community. Okay, so that's just an example of what we have been envisioning for FAIR data. That's what FAIR data would look like to us, following the 15 principles. But this idea of sitting down and writing out this provenance in a machine-readable format, maybe in RDF, or sitting down at the Fairfire console and building unique identifiers for your data elements, that's a daunting task for people who might be trained in biomedical research. So we see that there's a growing need to have people who are trained, but then even experienced. Over time, they're going to build up a wealth of expertise that is not going to be there if you don't do this every day. So in my job over the last couple of years and now going forward in GoFair, we've scoped out, I think, 4 different tracks of training, and we've been developing curricula and some training materials in these 4 tracks. So track 1 is just awareness, and that would be like an example would be what we're doing today, just kind of learning about the problems and potential solutions and how you might fit into that picture. Track 2 would actually be building up the skills that you would need to run the Fairfire, for example, or to understand what these 15 principles mean at a more operational level. It might mean working the data stewardship wizard, or we have also what we call bring your own data events, where you can have a particular data set, a real life data set for yourself, and in a 3-day period, you're given an introduction into what that verification process looks like. And then you can even see, in some cases, your data automatically interoperating with other linked data sources out there, which is kind of cool. There's all kinds of special topics we can imagine, but then also we're very interested in figuring out solutions for like train the trainer, because we feel like we need to scale this in a pretty rapid way. For example, to meet Europe's interesting request for 500,000 data stewards. And the training looks like this. We had these goals of kind of this Internet of Fair Data and Services. There were 15 principles developed in order to try and achieve those goals. We then developed the technology to implement those principles. So now we're trying to build the curricula that's required to understand and use that technology, and then try and figure out ways of certifying that. And this is one snapshot, given kind of the workflow that we've developed. This is one way of kind of seeing what this process could look like in reality. Imagine a day when in every research department, there's a data stewardship team at the end of the hallway, and there's one person who's just handling the data modeling. So the researcher is coming in and talking to this guy and saying, this is my experiment, this is my data, help me to create the data model that represents it. There's also someone who might be specialized in just the metadata, and they're going to build up a library of metadata models that will describe different kinds of experiments and procedures. These 2 things, the data model and the metadata, are handed over to the guy working the Fairfire. Those are requirements in order to do the verification. And then maybe there's another guy who is well equipped to do searches, very complicated searches on a world of fair data. And so, yeah, maybe there's, the client will come in, talk with the data modeler, he'll come in and talk to the metadata wizard, and there's a kind of consultancy aspect to this. That's where I'm going to stop right now. I don't know how we're doing on time. Perfect? Okay. Any questions? Any quick questions? Yeah? Oh, yeah. And we have microphones.
So a question that maybe is useful to ask at the outset. I can see how this applies to people who do primary research to generate primary data, and probably the majority of the people in the room do that type of work, but I think a sizable minority don't do that. And I wanted to know, what's the scope of your definition of data, and maybe an example is useful. So I'm a simulation modeler, and there will be data we'll calibrate a model to, we'll develop parameters, and we'll use those parameters with model code to generate results. The end results, I could see how I could share akin to primary data, but that's way less informative than the parameter values and the model code. So, and lots of other people who must do similar type of sort of secondary research as well. What's the scope of data, and how does it cover what I've described there?
Yeah, absolutely. So if I think as a computer scientist, data and software are both examples of data in a way. And running a simulation also is generating more data. So absolutely, I think one of the most frustrating things in computer science is that you have software, and then someone tries to reproduce your results. And even though they think they have the same parameter settings, the output is different. And so there's some work to show that even having different versions of operating systems running on a machine can lead to statistically significant differences in the output of your simulation. So keeping track of all this metadata that's related to the simulation is, I think, analogous to a laboratory experiment where, again, you kind of embedded the provenance metadata at the FAIR data point.
But does my analytical code also count as the data that I should share?
Absolutely. Absolutely. And it could have a unique identifier and rules for accessibility. Absolutely. Yeah.
Thank you. Hi, thanks very much for that. So my question is also about the type of data that you can use. And so we would have a lot of qualitative data in population health and health service research. How does that lend itself to the FAIR data principles?
Yeah, sorry, what kind of data did you say?
Qualitative data.
Yeah, so I think it's easiest to give examples in like tabular data, quantitative data formats. But there are ways of marking up data in RDF, qualitative data, that makes it completely analogous. So absolutely, having results from surveys or anything like that is something that you can also represent in a way that's machine readable. And
Okay.
yep. And again, it's sort of like the metadata is, in a way, the most important part. And so who are you? Where's your institution? What is your funding coming from? All these kind of high-level metadata are sort of things that we can all begin to start working out for ourselves, because that's going to be the same in every case.
Okay,
Yeah.
thank you.
Yeah.
Thank you. So where I have a difficulty of understanding is how this relates to the strict rules of data access and data governance. And to give an example, I mean, I'm a major user of secondary data sets and sort of studies which synthesize across data sets. And frequently when I try to access data which has been publicly funded, the collection has been publicly funded, the response is, but this was only collected for one purpose. That's a condition of use. So, yes.
Yeah, so one thing about FAIR data is that it will not, I think in my opinion, it will never say anything about openness or the licensing you put on it. It's only giving you the technical details about how the data can be accessed and under what conditions. So this is an issue of policy, I think, and whatever organizations are setting those rules and guidelines, I think need to, what FAIR data can do is force them to be more explicit about these decisions that they're making. And oftentimes I think when we are forced to be more explicit in our thinking and we begin to understand the implications better, it may engender a different policy. Yeah. And also with data quality, there's, I would like to think that FAIR data would say nothing about data quality, but it should say something about the provenance of the data and give you an indication of data quality just by the metadata that's on top of it.
As far as I understand, the metadata really becomes key from the accessibility of the data sets and searching. So I was just kind of wondering, how is GoFair kind of interacting with existing data repositories to ensure that the metadata being collected in all these different places actually is at some level equivalent enough to allow searching across different data repositories? Or
Yep, great question. So this is actually, it's this question that I think informed at a very early stage the design of the FAIR data point. And the reason I say that is because the FAIR data point itself is metadata, but it could be sitting on top of an existing repository or an existing data management system. So if you're thinking in particular about like patient record systems, and there's different vendors that have gone into hospitals or clinical settings, and now there's a large legacy of medical records that are kept in one vendor, and they don't talk to the medical records from another vendor. You could build FAIR data points on both of these repositories and choose which data you would like to share or exchange at the level of this fairness. So it allows people to become more fair in a relatively inexpensive way without having to throw out an existing system and build up something from scratch again. So that was the original, I think, intent behind the Fair Data Point, is to be this really lightweight layer that can go on top of existing repositories. But in GoFair, we work with RDA, and I just came back from a meeting in Washington, D.C. of the American Geophysical Union, and present there were geophysicists and publishers and data repositories. And what we envision at the GoFair office is that the decisions that are made in the AGU are decisions they will make, but maybe those should be coordinated with other bodies that are, other communities that are coming to terms with these issues themselves, and we can maybe try and find some alignment or catalyze more alignment than there would be otherwise. I don't know how much time we have now.
Probably can do the last
Yeah.
two.
Thank you. Just returning, I think, to an issue brought up by a previous person, the issue around, I suppose, the overlap between data protection and our ethical approvals and your GoFair and fair data. Because when we seek ethical approval, I mean, it is on the basis that in accordance with data protection regulations, that we only use the data for the purpose of which it's intended, and that it won't be shared with third parties. So how is this going to be reconciled, and are there knock-on effects for ethics committees and in the way we do our business and data protection nationally and all of that? Just like to comment.
Well, I think for such a large question, we have a simple answer. Well, it's just to say that I think to me, these are all issues of accessibility, and these ethics committees and the rules that they're operating under are setting the rules of engagement to that data, are setting the accessibility rules. Those can all be encoded and embedded in the metadata. And so anybody who's searching the landscape and finds this data set and it's relevant will automatically see that there's relevant data there, but maybe they don't have access to it unless they I don't know, fulfill requirements from the ethics committee in being able to attain that data. Does that help? Yeah, it's just the idea. It's really just trying, one of the programmers we have, he's a really young guy and he's building great tools, and he said, yeah, that fair data is just making everything explicit. That's all we're doing, is we're trying to find a framework where we can build incentives to make things more explicit. Otherwise, nothing changes.
It was the same question I wanted to ask, really, in terms of the implications for institutional review boards, because I guess those boards see their role as protecting information about people within that institution. So even if you embed that into the metadata, it has implications for institutional review boards. So if I'm on the institutional review board of a hospital and that data is in the fair data system, I could get applications for review from people all over the world for the data that's come from the particular hospital that I'm on the board of. So,
so you're saying like maybe conflict of interest issues?
No, I'm just wondering how, are you engaging with institutional review boards in any way? Are they a factor in this movement? How are they going to be considered?
Yeah, I haven't thought much about institutional review boards. I mean,
they are essentially the gatekeepers of the data. So if the accessibility to the data goes beyond their jurisdiction, there needs to be some gatekeeper.
Oh, I see what you're saying. Okay, yeah. No, again, I would see that as these are limitations that can be embedded in the accessibility of the review itself. So I think So fair data was designed to be as attractive to people who have closed and sensitive data as it is to people who have, open and freely available data. It wasn't designed in any means to be only for open, so it doesn't mean that when you're fair, somehow everybody needs to have access to it. In fact, you can really set in a much more precise way those accessibility requirements, and if a review board, if there's sensitive data associated with that, there's no need for it to be exposed any more than it would be in any other case. And then there's also, kind of a deeper level data stewardship decision is maybe some data just doesn't need to be public at all. Right? Maybe there's just information out there that's private and personal or sensitive, and it's a decision of the data steward as to what's going to go online anyways. And for how long? A data steward needs to be able to decide what's the lifetime, what's the usable, viable lifetime of data. And maybe it's forever, but maybe it's only for 5 years, given budget constraints. So you have to make those decisions. Good? Okay. Yeah, good. So, okay. Thank you.